Hey, this is the first of 4 videos we're doing that will capture the content of the lecture that was given today on February 7th. Classes were canceled after 2 o'clock, so some people did not get to see this lecture. So this will substitute for that, and if you watch these 4 videos, you should be ready for the exam on Monday. So there are 4 videos, and they correspond to the 4 pages of the handout that I gave on February 7th. That can be downloaded from the handouts. You can go to the to Blackboard there and click on the handouts link, and that will take you to my OneDrive folder, and you can see the handout there for I believe it's section 3.3 part 2 or something like that. And so it starts with this page that you're seeing on the screen right here. So it's page 3 of 3.3, but for the particular day that we're doing here, which is day 7 of classes, is it's the first page on the handout. You'll see it. So anyway, this first example here we're looking at is we talked about the product rule in class the other day and how to take the derivative of a product. And this is talking about how do we extend that to more than just one pair of factors. The product rule told us how to take the derivative of things that are, multiplied together like this. Now here just be a simple example. Something like this. Those are just 2 factors multiplied together, and so when we take the derivative of that, you take the derivative of the first factor times the second plus the derivative of the second factor times the first. But what happens when we have a situation like this, where we have 3 things multiplied together, 3 factors or functions, if you will, and then want to take the derivative of that? So how we do that is the following. So if we have f of x times g of x times h of x, and we want to take the derivative of that, then we would just take the derivative of the first function times the other 2 as they are without differentiating those, plus, and then we basically move the prime down the line, as we say. So we're just going to, the next thing will be we'll take f of x times g prime of x multiplied by h of x. And then lastly, we would take f of x times g of x times h prime of x. So you can see that each time all 3 functions are listed and then added together, but the prime is on the first one in this first term, and then the prime is on the second one in the second term, and so on. So that's how you take the derivative of 3 factors multiplied together. And then it's a similar way of doing things here if we have, in this case, 4 factors that are multiplied: f of x, g of x, h of x, and k of x. If I take the derivative of that, then it's going to, again, move the prime down the line. So we're going to start off with the first one, f of x, f prime of x times g of x times h of x times k of x. And then add on to that f of x times g prime, this time is the second one, h of x, and k of x. And then I'll move down to the next line so we can see this. Plus, and now, so we've primed f, g, and now the next one will be h. So h of x, excuse me, erase that. Okay. So back to this. So we'd have f of x times g of x times h of x, h prime of x this time, times k of x, and then the last term again would move the prime to k of x, so f of x, g of x, h of x, and then k prime of x. So this just shows how you can expand or extend the use of the product rule when you have more than just two factors. An example of this, and we're not going to work the whole thing out, we're just going to kind of set it up. In class I had people break down into groups and we worked on each part of this derivative. So here you have the derivative of, here's our three factors. So this was right here is like our f, this is like our g, and this is like our h. So f of x times g of x times h of x, and we're taking the derivative of that product of three factors. So here's how it would work. You would take, the first factor here, and we'll write it out. It would be 3x squared plus 5x minus 2. So we would derivative that times the other two. So I would go ahead and, like we've done in class, we're going to take all the radicals and change them to rational powers, like fractions. So this would be x to the 1/5 plus would be 3x to the negative 1/2, and then times e to the negative x. Make that so it's not a fraction anymore, plus 7. So that would be the first thing that would need to be done, and then add on, so it would be add on to that, so we're going to have to wrap around to the next line. Then we'll move down and we'll take the derivative of the second function, so it would be, the first function as it is, 3x squared plus 5x minus 2, times then the derivative of this x to the 1/5 that we wrote, plus 3x to the negative 1/2, and let me get back here. So we're going to take the derivative of that times e to the negative x plus 7. And then lastly, we would add on to that, again I'm just wrapping around the next line, would be the 3x squared plus 5x minus 2. And then that would be multiplied by the second function, x to the 1/5. Oops. Come on. And then plus 3 to the x to the negative 1/2. And then we're going to take this last one, I'm going to rewrite it back as 1 over e to the x, because you don't know, well, most people don't know yet how to take the derivative of e to the negative x. So you can use the quotient rule on this 1 over e to the x plus 7, because this is the factor we're taking the derivative of that time. So we didn't work this all the way out in class. It's rather lengthy, but I want to kind of use an extreme example just to see how this would work. It's the mechanics of this that you need to understand. Whether you can take this all the way out and take the time to do that, that's fine, but you need to see how you would take three factors that are multiplied together and then how to take the derivative of those. So these would have to be expanded out For example, we'd have to go ahead and take, what is the derivative of this, and once you figure that out, multiply it by these two terms, and then once you get the result of that, multiply it by these two terms, and so on. And that would give you that part, and then you'd have to add on to that, what's the derivative of this factor, and then multiply that by, one of these other two factors, and then take the result of that and multiply it by this three terms. So, it goes on down the line. So it's an involved process here, because the functions are kind of challenging. But I just wanted to get the concept down. So, and that's all that we're doing on this first page here is just simply looking at how to extend the product rule to three or more factors.